Okay, so basically in this video we are just going to be talking about trigonometry. We are going to give ourselves a general idea, a general overview on or about what trigonometry really is. Okay, so just as the name starts, it's trigonometry. So it's more like a type of geometry that is usually associated with triangles, because the word tri here means three, and a triangle has three sides. Okay, one, two, three. So think of trigonometry as just a type of geometry that is associated with um, triangles. All right. Now, triangles are in many different types, if you ask me. But I'll try to classify triangles based on a type of angle referred to as the right angle. Okay, referred to as the right angle. I'll try to classify triangles in terms of the right angle. In math, right angle, the right angle is usually 90 degrees. So any triangle that is going to have the 90 degrees angle with it, that is going to have the 90 degrees angle, the right angle with it, that triangle will be called the right angled triangle. It's right angled in the sense that it's having a 90 degrees with it. But if you maybe look at this simple sketch which I have made of a triangle, you're going to see that we're not seeing any um, right angle present. We're not seeing any 90 degrees angle present. So because there is no 90 degrees angle present, then this one is a non-right angled triangle. So this is non-right angled in the sense that it's not having any 90 degrees angle with it. So this is a right angled triangle. This is a non-right angled triangle. Now, under the trigonometry, the way we handle questions or the way we discuss things about the right angled triangle is very much different from the way we handle things under non-right angled triangles. Like a good example, when you are talking about right angled triangles, we normally connect right angled triangles with what we call trig ratios. So anytime you're talking about trig ratios are usually, um, can I say, assigned, okay, or discussed largely um, under right angled triangles. And basically, we have about three trig ratios. We have the sine theta, which is opposite over the hypotenuse. We also have the cos theta, which is the adjacent over the hypotenuse. We also have the tan theta, which is just the opposite over the adjacent. Okay, so these are just the three basic ones that we have. For those of you maybe perhaps who take additional mathematics, we can also put what we call the cot theta or the cotangent. The cot theta is just the same as 1 over tan theta. It's an inverse of tan. Okay, 1 over tan theta, and this one can be written as cos theta over sine theta. Okay, the fifth one, we also have what we call the secant or sec theta, sec theta, which is just 1 over cos theta. It's the inverse of cos. So think of this, if cos theta was like adjacent over hypotenuse, then the 1 over cos theta is going to just be like hypotenuse over adjacent. Okay, yeah. And then the sixth one that we can put here, we can now talk about the cosecant, which I sort of like said, the cosecant, but usually written as cosec theta, which is just going to be 1 over sine theta. So for those of you who take additional mathematics, this is just like extra information that you can get. But under ordinary math, just sine theta is equal to opposite over hypotenuse. Tan theta will be opposite over adjacent. And again, tan theta is just the same as sine theta over cos theta. Sine theta over cos theta. Of course, this is um, usually used or practiced in additional mathematics problems, but it's still fine for the sake of just knowing these things. So sine theta is equal to opposite over hypotenuse. Tan theta is opposite over adjacent. And the other identity for tan theta is just like sine theta over cos theta. Cos theta is just going to be equal to adjacent over hypotenuse. Yeah, adjacent over hypotenuse. Cot theta, or the cotangent, this is like 1 over tan theta, which can also just be written as cos theta over sine theta. But if you want to express it in terms of the opposite adjacent thing, if tan theta was like opposite over adjacent, then your cot theta can be written as adjacent over opposite. They're just opposite. Okay, they're inverses. So your sec theta, this is like 1 over cos theta. So if you also want to express your sec theta in terms of the adjacent hypotenuse thing, if you notice, cos theta was like adjacent over hypotenuse. Your sec theta is like 1 over cos theta. So if cos theta was like adjacent over hypotenuse, then your sec theta is just going to be hypotenuse over adjacent. The same thing can also be said on cosec theta. It's just an inverse of sine. So if sine theta was like opposite over hypotenuse, then your cosec can also be written as hypotenuse over the opposite. Yeah. So when you're talking about right-angled triangles are usually associated with these trig ratios. Okay, they're usually associated with these trig ratios, and it's very easy. If maybe say theta is here, you're going to see that the side which is can I say facing, or which is just lying opposite to the angle here, this side is going to be called the opposite, because if you notice, it's like this side is kind of like facing this angle that we have here. The longest side is always the hypotenuse, don't forget that. And this side that is here, that's what we're just going to have as our adjacent. So it's very much important that you also learn how to identify um, the opposite, the adjacent, and the hypotenuse, because if you do not, can I say, accurately determine your opposite, your adjacent, and your hypotenuse, then that's going to be a problem. What if theta was above? What if the angle was here? How can it be? Well, theta here will be facing this side. So this side is the one that is going to be now called your opposite. The longest side is always your hypotenuse. And this side is the one that is now just going to remain as our adjacent. So your opposite and your adjacent can vary depending on the position of the angle in that triangle that you have been given. Of course, apart from the 90 degrees. So if it is here, then this is going to be your opposite, this is going to be your adjacent, and this is going to be your hypotenuse. But if you have been given a triangle in this way, then, and the angle has been put there, then this is the one that is now going to be your opposite. This is going to be your adjacent, and then this is going to be your hypotenuse. Now, these angles have special names, and you have to know them. If you see your angle is lying down there, well, the name given to it, we call this angle as the angle of elevation. Okay, we call it as the angle of elevation because it's like looking up. Okay, think of it as an eye, which is just like looking up there. So to elevate, okay, elevate. Now, this is the angle of elevation. The name given to the angle when it has been brought in this format, this angle up here is called the angle of depression. This is the angle of depression because it's like looking down, and someone who is depressed is more like low, so hence the name angle of depression because it's like looking down. Angle of elevation because it's more like looking up. So right angled triangles are usually associated with trig ratios. Apart from trig ratios, you also need to know that right angled triangles are also associated with what we call Pythagoras theorem. Pythagoras theorem. Yeah. Pythagoras was more like the name of a person, and in his statement, he fashioned a right angled triangle in this way, and then he assumed there were squares which were formed from these sides. So I know they're looking like rectangles, but let us assume these are squares. And let us imagine this is C, and then this is going to be A, and then this side, let us just put it as B. So let us imagine we are drawing squares. From each of these sides. And let us try to more like calculate the area for these. Having seen that it's a square, then if this is C, then this will also be C. And if this is B, then this will also be B. And if this is A, then this is definitely going to be A. So I can just put it like this. So in his statement, he said that the square of the hypotenuse, is always equal to the sum of the squares of the adjacent sides of the right angled triangle. So Pythagoras' theorem is only restricted to right angled triangles. So he said that the square of the hypotenuse, which in this case is c, so when I say the square of the hypotenuse, I mean c squared. He said that the square of the hypotenuse is equal to the sum of the squares of the two adjacent sides of the right angled triangles. So if I was to find the square of A, the square of A is just like this. Remember, he said that the square of the hypotenuse is equal to the sum. And anytime you hear sum just means addition. So if this is A squared, then this would definitely be squared. This would definitely be B squared. So this is where this formula comes from. So he summarized this statement into this formula. Okay, he summarized this statement into this formula. All right, to this formula. So this is Pythagoras' theorem, and it is associated with only right angled triangles. Right angled triangles. All right. So just a quick problem. Let us say maybe you have this. Maybe say this is 3 centimeters, this is 4 centimeters, and then you're trying to find x. Definitely what you're going to use here is Pythagoras' theorem. So in this problem, it just be like c squared equal to a squared plus b squared. So this is just going to be like 3 squared plus 4 squared. This is 9, that's 16, and that's all going to be equal to 25. So c squared would be equal to 25, and the square root of this whole thing is just going to be 5. So that's it. Your x value here is going to be 5 centimeters. So that's Pythagoras' theorem. And for the sake of maybe um, someone maybe who is making some revisions for mathematics paper 1, where you're not allowed to use a calculator, and uh, usually no demand is made for you to show your working, I want you to just master this pattern, and you can try to prove this using Pythagoras' theorem. The first one is this same one. If this is 3, if this is 4, then this is going to be 5. The other one, which I can give you for the sake of practice, and you can prove this thing if you want. If this is 6, and if this is 8, then you can be very well sure that this is going to give you 10. If this is 9, and this is 12, then this is going to be 15. And then the last one I can give. If this is 5, and this is 12, the hypotenuse is definitely going to be 13. These are 4 common right angled triangles which I even brought in the exam. In the case maybe I write in mathematics paper 1. So you just need to know the pattern. If you want, you can master the pattern, or More importantly, just know this formula and know where to put your C, know what to put on your C, on your A, and in your B. So that's what we can say about right-angled triangles. This is a brief introduction that we can give about it, to say that right-angled triangles are associated with trig ratios and also the Pythagoras theorem, which we've just worked out briefly up to that point.